صل على سيدنا محمد وعلى آله وصحبه.
الحمد لله رب العالمين والعاقبة للمتقين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله الطيبين وأصحابه الطاهرين. أما بعد فأعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. إن الله وملائكته يصلون على النبي يا أيها الذين آمنوا صلوا عليه وسلموا تسليما.
اللهم صل
على سيدنا محمد وعلى آل سيدنا محمد وبارك وسلم. صلاة وسلام عليك يا سيدي يا رسول الله وعلى آلك وأصحابك يا سيدي يا حبيب الله. Most Honorable Mufti Islam, Ulama Mufti Sahib, and most honorable ulama, respected audience, I'm absolutely humbled and honored to have been invited to say a few words regarding the issue of school times in the summer months in the UK. Inshallah Aziz, I will be tackling this issue from scientific perspective, especially for the younger audience and the English-speaking audience. The dalail from and the proofs and evidences with respect to fiqh and the fuqaha and the sharia you've heard in detail, and inshallah you will hear further proofs and evidences. And all of those proofs and evidences, I'm not going to repeat them because in order to repeat every single one of them, I would have to take as much time as everybody else is taking collectively. So I'm just going to hint towards them, and I'm going to move on, and I'm going to tackle this issue merely from a scientific perspective. Because as we've heard before, as my honourable colleague Molana Sahib was saying, that calculations, mathematics, is known and proven to be absolutely precise. And therefore, we need to understand also that this formula or this methodology which is being proposed is not something that only the fuqaha have proposed. This is something which is quite substantially proved and backed by Muslim astronomers as well as scientists, non-Muslim scientists, and modern science and astronomy also proves and is heavily stacked in favor of this proposal. In order to do that, there's some basic terms which you need to understand and which I need to explain. And my apologies to anyone who's already familiar with this, but because it would be impossible to actually understand the whole concept without knowing this, so therefore for the benefit of those people who may not know this, I'm going to have to explain some of this terminology. The first slide that you see in front of you, the first image, is an image which shows the path that the sun takes relative to the observer, which you can see there, the stick person that stood there, the path that the sun takes relative to the observer. But what does that mean? You might ask the question, well, we've been taught at school that the earth rotates on its axis and rotates around the sun, and yet you're saying the path that the sun takes around the earth. Well, relative to the observer, this is how it appears, and you can understand this by thinking of two trains on a platform. When you're sat inside one train and the other train moves from the platform, until it's actually moved away, you have this sensation that you're moving. And similarly, relative to the observer, this is the path that the sun takes around the earth. And as you see, it is a circular orbit. And we all know, all of us who've been to school and studied any amount of mathematics, we know that a circle consists of 360 degrees. So this is where the terminology of the degrees actually comes from. It's the route taken by the sun around the earth, which is a circular orbit which is split into 360 degrees. And when the sun is at its highest point and it's at its peak of its activity, known as the zenith. This is referred to as 90 degrees, with the horizon being 0 degrees. And you understand that this makes a right angle, so a line straight up and on the vertical, a line on the horizontal where they meet, you'll have a right angle. This is 90 degrees. And so you have either 0 degrees or 180 degrees on the other side. If we move on to the next slide, this will actually show you how the path that the sun takes, or relative to the observer, the path of the sun actually changes depending on the season. So as you see, during the winter, the path above the horizon is shorter, which means because it's a circular orbit, therefore the path below the horizon must be longer. And this is why we have a long night during the winter. And you see the path in the summer being far higher above the horizon, and therefore must be lower below the horizon, which means the shorter nights in the summer. So this is why we have, in the summer, we have the sun only dipping to maybe just about 11, 12 degrees below the horizon. Whereas in the winter, you might find that it goes way below to down to 50 or 60 degrees below the horizon. This is why we have the difference in the days and nights. Now, from a scientific perspective, we understand that the sun, and we know, and not just from a scientific perspective, it's very, very clear that the sun rises in the east and sets in the west. And as the sun sets, following this circular or elliptical orbit, the sun depreciates and goes further and further below the horizon. But the sun actually is the light of the sun scattered on the horizon, and due to something, a phenomenon known as refraction, is still visible on the horizon. That's also depicted in one of the slides. The next slide, which shows the diagram. This diagram actually shows how refraction takes place. Very, very simply put, going back to your school days, this is the sort of experiment where you stick the pencil in a glass of water, and you see that it bends. So when light enters a different medium from before, it bends. Therefore, as you can see from this actual diagram, this is the lower position is the actual position of the sun, which is below the horizon, but due to refraction, it appears to the observer to be actually above the horizon. This is why we have a gradual transition from light to dark, and then in the morning from dark to light. Otherwise, it would be sudden, like the click of a finger, you would be on and off like a light switch, that morning and day in a light, like a light switch. For this reason, it doesn't happen in that manner. What actually happens is, in the evening, the sun sets, and at first, you see, at the sunset, you see a red glow appear on the horizon. In terms of fiqh, this is known as shafaq ahmar. This is the red shafaq, or the red twilight. And when this disappears, you have a pale glow on the horizon. Now, because this pale glow is visible on the horizon in the backdrop of a blue or dark horizon, this, in terms of fiqh, has been referred to as shafaq abyad, as the white twilight. When this finishes, then you have night. So what is actually happening is, if you envisage the first example that you saw, the first diagram that you saw, the sun setting in the west is going further, is following this circular path, and it's going further and further below the horizon. It reaches 6 degrees, which is shown in the next slide. It actually shows the different levels of twilight. So you have daylight, and at 0 degrees, or just below, we have sunset, and then from 0 to 6 degrees, we have civil twilight. It is the end of civil twilight, which is when all, for civil purposes, it is then deemed to be night. For example, the street lights will come on at this time, and that would be deemed as the end of civil twilight. When the sun goes further below, following its circular path, and when it comes to an angle of -12 degrees, this is the end of nautical twilight. So between 6 and 12 degrees, you have nautical twilight. And then traveling further the sun, when it reaches an angle of minus 18 degrees below the horizon, this will be deemed to be the end of astronomical twilight. And as you can see, gradually getting darker and darker until when you reach exactly and precisely 18 degrees, you are then entering into the night. In other words, the last light directly from the sun, scattered or by way of refraction, is no longer available on the horizon. This is as dark as that night sky is going to get. So this is night. You have the opposite sequence, because remember it's following a circular path, so you have the opposite sequence in the morning for sunrise. So you have, if you imagine this being the other side, this being superimposed on the other side, you'll have the sun following the circular path, coming up, back up towards minus 18 degrees, and this is when the first light then spreads across the horizon, horizontally, spreading constantly until you have full daylight. This is what the scientists say, and this is unanimously agreed upon the world around. We have to then apply these rules to what we know as the definitions of Subh Sadiq and Fajr in light of the Quran and Sunnah. Now, there's no disagreement regarding the fact that Fajr begins at Subh Sadiq and that Suhoor ends simultaneously at the beginning of Subh Sadiq and at the beginning of Fajr time. And Fajr, as described by the Prophet ﷺ, we had a detailed description by Molana Nizamuddin of Fajr being horizontal across the horizon and spreading continuously until you have daylight. Now, these conditions are only met when the sun is 18 degrees below the horizon. We all know that the earth is spherical, or slightly oval, but more or less spherical. Therefore, it is agreed upon by the scientific community, wherever you are in the world, whatever season it is, you will only have astronomical twilight, beginning if the sun depreciates below 18 degrees during the night, and when it comes back and reaches 18 degrees, this is when you will have the beginning of astronomical twilight, or the beginning of first light. No matter where you are in the world, no matter what season it is. This is very, very simply understood. Or for those of you who have studied physics, you will understand that the refraction of light and all these phenomena, they have to occur under very specific conditions. How is it possible, I simply ask, if we don't affix the same degree? And this is clearly, this diagram explains how the range of light on the horizon actually changes and diminishes down to 18 degrees where it ends. How is it possible for the sun or for the horizon to appear the same? For example, if the sun was at 10 degrees below the horizon and if it was 20 degrees below the horizon. Right? The sun is here and it's here relative to the horizon. How is it physically possible for that spectacle to appear the same on the horizon? This is not possible. So we understand then, from a scientific point of view, it is absolutely clear without a shadow of a doubt that for the first light to appear, for astronomical twilight to end and to begin in the morning, to end in the night and to begin in the morning, the sun must be 18 degrees below the horizon, wherever you are in the world and whatever the season. If we move on to the next slide. This is just an explanation of the diagram which I've already given you, so we'll move on. There's some definitions here of the different twilights. Astronomical twilight begins at 18 degrees. This is known as astronomical dawn. It ends at astronomical dusk, which is in the evening when the sun reaches 18 degrees below the horizon. And astronomical twilight is a period where the center of the sun is between 12 and 18 degrees below the horizon. So this is a scientific definition of astronomical twilight. Moving on, you have definitions of nautical twilight when the sun is between 6 and 12 degrees. And also we have civil twilight when the sun is between 0 and 6 degrees. And during civil twilight, it actually mentions there at the last point that the sky is still illuminated, and with clear weather, it is the brightest in the direction of the sun, and the moon and the brightest stars and planets may be visible. It is usually bright enough for outdoor activities without additional lighting. So that's just from a scientific perspective, that's a definition of the 3 twilights. If we move on, that's something that I've just mentioned. It is agreed upon by the scientific community that the first light from the sun that appears on the horizon is when the sun is still 18 degrees below the horizon. That is in order for this, and in order for the same physical conditions to be replicated on the horizon over a number of days, the sun would have to be at the same altitude on all of those days. So moving on, the next thing is the definition of twilight in light of the Quran and Sunnah. I've already explained light that spreads horizontally across the horizon, continuously spreading until you have complete daylight. And finally, this is not just a view that is endorsed by the scientific community. We have a slide where it actually tells the 18 degrees is something which is substantiated by many number of scholars, of 10 different scholars that I've given a reference to here. That below are some names of some of the scholars and Muslim astronomers and scientists who have held this view that astronomical twilight, or the first light in the morning and the last light to disappear in the evening, happens when the sun is minus 18 degrees below the horizon. Imam Batani, Imam Al-Biruni, a whole list of 10 different people, ranging from scholars way back in the 3rd century Hijri, going back to the 3rd century Hijri. If we go to the previous slide, what do we propose under normal conditions? Under normal conditions, there is ijma, there is consensus, which is mentioned previously with the reference to Imam Ahmad Raza rahimahullah ta'ala and his book Taj al-Tawqi, and also the scientific community and the rest of the entire Muslim world, and also a huge number of scholars of the highest magnitude all agree unanimously that under normal conditions, when the sun reaches 18 degrees below the horizon, and in the evening, this is the end of astronomical twilight, and this is the beginning of Isha. And in the morning, when it approaches 18 degrees below the horizon, this is when the first light will appear on the horizon, and this is Subh Sadiq, this is Fajr time. The problem is, in the UK, during the summer months, the mid-summer months, from May, June, July, up until, for some parts, up until August, the sun does not depreciate to minus 18 degrees below the horizon. If you think about the second slide that I showed you, about the varying parts of the sun, this slide here, during the winter, the sun has a larger path to travel below the horizon. So it goes further below the horizon, so you can imagine this path going all the way around and coming back up. But during the summer, the path is much shorter. It stops there, and it's coming right back up. So you have the sun not even going 18 degrees below the horizon, some places not even going below 12 degrees. And so you have a persistent twilight, what is known as a persistent twilight, which lasts all night long. What are we to do then? How do we determine when Maghrib ends, and what happens with Isha, and when does Fajr begin? This is the problem that we are faced with. Now, from a scientific perspective, and first of all, I want to address this issue from the perspective of fiqh. And under the guidance of my honorable shuyukh and tutors, I just want to say one thing. With my diminished understanding, a minimal understanding, if we were able to substantiate that even during the summer months, Fajr begins, we have an actual beginning of Fajr, then there is absolutely no validation for any form of taqdeer. For any form of taqdeer or appointing a time or affixing a time, whatever kind it may be, there's no validation for it if we can prove that even during the summer months, even with persistent twilight, Fajr actually occurs. Now for this, what I need you to understand is Imam Ahmad Razak rahimahullah and other scholars have quite clearly stated that for Fajr to occur, it is not necessary for the western horizon to be black. It is the eastern horizon where there should be darkness, and when the light appears on the eastern horizon, this constitutes Fajr. So any light that appears on the eastern horizon horizontally, spreading continuously until you have complete daylight, this constitutes Fajr. When does this happen? The scientific community agrees on this, and we have a slide from Royal Observatory of Greenwich, which is taken directly from a presentation which was delivered by Dr. Steve Bell a few weeks ago in London, not many years ago, a few weeks ago in London, and he delivered his seminar on twilight and the prayers around the twilight. And this is coming from a non-Muslim perspective. So we can't exactly go and tell him, what time is Fajr going to begin in midsummer. He's not going to give us that answer, but he can give us some rules and some indications as to what the scientific community says regarding these issues. So one of the questions that was asked, question number 2 there, is in these days, astronomical twilight does not disappear from the horizon. You have persistent twilight. At what times does it move from the west to the east? I've not written this. I've just copied and pasted this from the slides and from the presentation that he forwarded to us. And he answers, this is his answer, the sun moves from the western half of the sky to the eastern half of the sky at lower transit. For those of you who don't know what lower transit is basically the middle of the night. You have 90 degrees at the top, and if you draw the line all the way down, you have 0 degrees there, which is lower transit. So as the sun crosses through lower transit and it goes towards the eastern horizon, that light, that twilight shifts from the western horizon onto the eastern horizon. So this is what happens effectively during a summer night. You have persistent twilight because the sun has set in the west. It first appears in the west, and then gradually, as the sun follows its path, crosses through the middle and moves towards the eastern horizon, this light then gradually shifts towards the eastern horizon. This is, by definition, the first light on the eastern horizon, spreading horizontally, continuously spreading until it becomes clear daylight, which meets all the criteria explained in the Sunnah regarding the Fajr time, and therefore, even in midsummer, you actually have a start time for Fajr. So therefore, I think, I don't believe that there's even any need to discuss or entertain the issue of taqdeer or appointing a time if we could only agree and we could actually if this became unanimously agreed that there is actually a start time for Fajr. Another view, which actually something which also helps us to understand and support this proof, the further proof of this lower transit is that based on knowledge from the fuqaha and based on many observations, we understand that the length of the duration, the length of Maghrib and Fajr is always equal all year round, wherever you are in the world, whatever season it is. Under normal conditions, the length of Maghrib and the length of Fajr is always the same. Going back to, because, and I saw a slide earlier which was depicting both twilights on one diagram, it's just it's symmetrical. You could put a mirror down the middle and it's symmetrical. Whatever happens here happens in reverse order in the morning. Therefore, Maghrib time, because Maghrib begins at sunset and ends at the end of astronomical twilight, that's the same distance, and because Fajr begins at the beginning of astronomical twilight and ends at sunset, it is the same distance. You have 0 to 18 degrees here and 18 to 0 degrees on the other side. It's exactly the same distance, and it always is, as you can see in that diagram there. It's exactly the same, and it always is. Now, technically, we understand and we believe that according to the madhab of Imam Abu Hanifa rahmahullah ta'ala, during these months, technically, there is no Isha time. When we believe that technically there's no Isha, what are the two remaining times? You have Maghrib, which begins at sunset, and then you obviously have Fajr because you have light on the eastern horizon before sunrise. How do you distinguish then between Maghrib and between Fajr? Using that formula which has been given and tried and tested the world around by the ulama, that Fajr and Maghrib are always equal duration, again you would have to apply this rule of middle of the night to come to that conclusion. And then you have the same time for Maghrib and the same time for Fajr. And you also know that at that point the twilight on the western horizon shifts towards the eastern horizon. Now this is heavily, again, not only just supported by the scientific community, we have support for this from many scholars and Muslim scientists alike. In Imam Qutbuddin Shirazi. Now all of these texts, the actual references are available here. You can see these stacks of books. I'm not going to go through them. Imam al-Mardini, Imam Abdul Ali al-Birjindi, Imam Ahmad Raza rahimahullah, Mufti Sayyid Afzal Hussain, and many more who've actually given us this proposal of using middle of the night for end of prior to that, we are to do all our activities relating to Maghrib and Isha and Suhoor, and then middle of the night is beginning of Fajr time. So this is quite considerably supported not only by the scientific community but also by our ulama as well. So in conclusion, with this particular proposal, the conclusion is that the only solution which is accepted by scholars, also conforms to modern scientific principles, is that the commencement of Fajr and Isha is when the sun reaches minus 18 degrees below the horizon, either side. But in those summer months, at those altitudes where there are some days when the twilight is present all night, it persists all night, the only logical solution then is to actually use the middle of the night when the twilight shifts from the western to the eastern horizon as the starting of Fajr, knowing that the conditions of Fajr as described by the Ahadith are then fulfilled. So this is the conclusion that we come to. And there are a couple of other slides there which actually deal with other options. Just going to spend a couple of minutes on this very briefly because we have Molana Yunus who's going to actually be discussing the other options. What are the other options? First of all, I've said when it becomes clear that Fajr actually begins at some point in a summer night, Fajr begins. Therefore, we don't actually need to look for alternatives. But discussing the alternatives, you have Aqrabul Ayyam, Aqrabul Layali, as it, either way, what is referred to. Basically, this is using the last day when minus 18 degrees was available and affixing that time or appointing that time throughout those days where you do not have, where the twilight is persistent. The problem with this is easily available, readily available information. If you search on the internet, you will find various different calculators. You can go on the Almanac website and take those timings from there. And you will be able to calculate the time of Fajr according to 18 degrees. And you will find that the very last time, on the last day when Fajr actually occurs, and on the next day, after a few months when it first reappears, is close to 1:30. what legal principle do we then have of allowing people to eat for a further half an hour? This is something that needs to be, this is one major question. The timetables, taken from various universities. First of all, the timetables that came to me, they were not taken from these various universities, they were actually taken from IslamicFinder.org. Let's put that straight. Secondly, the Karachi University, which is referred to, is not actually the government, the University of Karachi under sort of the government of Pakistan. This is either of two madaris belonging to other sects. And Egypt University, it's not actually Egypt University, it's a company which deals with their data. And Qura, the thing is though, I urge you to go on to IslamicFinder.org or .com, whatever it is. I urge you to go to that website and select the option for changing the the method of calculating Fajr and Isha. And when you go there, it will give you all the different options. And it will also tell you how they calculate Fajr and Isha. And I guarantee you, each and every one of them is at least 18 degrees. Egypt, Karachi University, both 18 degrees. Qura, 18.5 degrees, even earlier than ours. So I urge you to actually check this and then use that data on the Almanac website to get those timings of 18 degrees, and you yourself will see how big the discrepancy actually is. 15 degrees, I'm not going to entertain that. We'll leave that for another time. We've already talked about the different issues. If you look for the closest city, then which direction are you going to go in? Or closest town, country, which direction are you actually going to go in? You come into a lot of stumbling blocks, a lot of problems. The bottom line here is no Hanafi jurist at all has given any support for appointing or affixing a time for suhoor, for fasting. The only sort of the only text and references that are available for ever affixing a time is in relation to prayer, not for fasting. So this is something that has never even been indulged in by the Hanafi fuqaha. And there's one last one, which is, there's actually a table of times. Yes, this is a table here. Now this is a timetable also being used in some places as well. What I've done there is I've calculated, you have the starting time of Fajr on the 1st of each month and the 15th of each month. And next to that you have the corresponding altitude of the sun. What altitude the sun is at. And you can see that this ranges from 12.02, 12.55, 13, 14, 15, 17. It ranges from 10 all the way to 17. There is a difference of 10, there's a difference of 7 degrees in this timetable all year round. Sometimes it's at 10 degrees, sometimes 11, sometimes 12, sometimes 15, sometimes 17. Why has this happened? I'll tell you why this has happened.
Wow.
This has happened because the time has been affixed. 1 hour 20 minutes in the summer, 1 hour 40 minutes in the winter. And this is what you end up with.
Wow.
Why? Because twilight, scientifically it is proven that twilight is not the same duration all year round everywhere in the world. The duration, the length of twilight changes even in one place throughout the seasons. Twilight is never constant and never sort of the same duration all day in, day out, all year round. When you start to affix a time for the twilight, this is the problem that you run into. And the final sort of diagram which discloses the problem of this this one here, this shows you very, very clearly the flaws within this particular timetable of affixing 1 hour 20 minutes or 1 hour 40 minutes. What happens? Effectively, one day you've got Fajr happening there at minus 10 degrees, and one day you've got it there almost minus 18 degrees. Now when you're stood outside there, and it is these people that actually claim the mushahada, right, the observations. I ask you, alhamdulillah, as a very sensible and knowledgeable audience, if you're stood there observing the horizon, is it possible at all to have the same spectacle when the sun is only there and when the sun is there? Logically, scientifically, anyhow, is that ever possible at all? So there are your other options. So in conclusion, again to conclude, this is something which is supported by senior ulama and fuqaha of the Hanafi madhab. It is supported. Now, obviously, like I said, they're not going to give us an exact time because we're asking a non-Muslim organization, but it is supported heavily by the modern science and the Royal Observatory of Greenwich as well. And this is the safest option as well when looking at it in that respect. If you close your fast early, you're not likely to actually to invalidate it. So the safest of options, the best of options in my humble opinion, and also supported by my shuyukh and the ulama. My apologies if anything I said has sort of been any sort of distress for anybody. Jazakallah, thank you very much.